Hey guys, welcome to Velotio Tech Shorts, and I'm Yashasvi. I'm a senior software engineer here at Velotio. I've been into the software development industry for about 5 years now, and this tech short is a two-part series on servers and events. So without further ado, let's just quickly look over the agenda for part one. In part one, we'll first go over the overview of servers and events. We'll define it. We'll see what are the different examples and use cases where we can use servers and events. And then I have a small example walkthrough of an application, if you can call that application, which basically demonstrates the use cases of servers and events. Next, we'll look over the specialized use cases and different examples that are being used currently in the industry. And we'll close it up with the overview of how it works under the hood. We'll look over the protocol definitions of servers and events and compare it generally or understand it how it works internally. All right, let's define what exactly is servers and events. Servers and events are essentially a server push technology which allows clients to receive data in real time from the server without reconnecting to the server. Now, this seems fair enough, but why this server send existed in the first place? Now, if we go into the depth, we know that the entire request response cycle or the API that we are commonly known about is based on HTTP. Now, HTTP is a stateless protocol on its own. We do make it stateful by putting in cookies and headers and allow the server to actually identify which client it was. But it doesn't give you the means to actually keep the connection alive and send data towards the client with just one connection. What it essentially means that if there is one request to get the data, the moment the client receives the data, the connection is closed. This is what the problem was if we want to stream data from the server to the client. Now uh, we have to note that server sent events are one directional or unidirectional, which means that only the data can be transmitted from server to the clients. It's not possible to send data from client to server in real time. This is where WebSockets would come into the picture. But server sent events in comparison of WebSocket is essentially much more easier to implement and has less overhead. We would be doing a little bit more in-depth analysis of it into the later slides, but let's just quickly glance over how it works. So essentially what happens the moment you come into the web page, you have, of course, your front end code and your back end code, but your client essentially creates a connection with the server. That happens once, and once the server acknowledges that that the connection has been made, it then is easily able to transmit data towards the client without reinitialization of the connection. So as long as the client and the server is up and running, server can painlessly can transmit data without any issues. Now, we do need to note that server sent events are compatible with only text-based messages. We cannot send binary messages. We'll talk about it in a later slide, but this is the entire gist of what server sent events are. All right, now let's just see a simple example of what server sent events can achieve. Imagine a restaurant-like scenario in which on the left-hand side is the UI where the user will be able to, let's say, order food or something like that. And on the right-hand side is the UI which the restaurant is seeing, which needs information in real-time basis of the new upcoming orders and if some of the orders are cancelled or something like that. So on the left-hand side, you'll see that I have a message box in which, let's say, I write pizza, for example. And just for the sake of it, I specify order created. The moment I click on send, I see that order created, a card like that appears on the right hand side or on the restaurant side. So what essentially has happened is on the left hand side or on the user side, we have created a HTTP request which is going to the server. The server triggers an event in the backend, and that event gets called or processed on the server and gets streamed to the right hand side UI or the restaurant side. So everything happens in real time. So if I say, let's say, for the sake of trivialness, let's say some random order, and in this case, this was, let's say, an order cancelled. Of course, you can have more logic to it, and can increase the business logic here and to handle it in a better manner. But just to give an example, right? So as you can see, the moment I clicked on send for order cancel, it came in here with little to no delay. Similarly, what I have done here is when I say none is just a simple message body which just goes into the client side or the restaurant side and then gets displayed as a message. So let's say uh, new payment received, and how this is going to be perceived on the restaurant side is just like a notification which is coming here, right? So this is a very simple example, and these all are event names or what we call, you can label these event names to your event streams, and you can handle it separately based on some logic, which we'll go over into the inside when we go inside the code example thoroughly. But this is what the simple example of what server sent events can do. Let's move on to the next slide. All right, now let's just see a few more use cases of where we can use server sent events, and also some examples where it is being used currently. So the entire idea about server sent events is that it should be having low latency, should be simple enough, should have little to no overhead. It makes it easier for the developers to integrate that technology and have a real-time connection from front end to the back end. Right. So since it is text-based, it allows you to do that. Remember, a point to be noted here is server-sent events cannot be used to transfer binary data directly. Of course, there are ways for it, but it's not recommended, and we'll talk about it when we are talking about the limitations. Ease of use is the second best example, that you have a use case that you don't want too much of an overhead like WebSockets and polling, which is we'll be comparing in the later slides. And server-sent events also comes with auto reconnect and no unbound buffers, which means that you don't have to handle connections closing and connections reconnecting. All that is done fairly easily, or let's say with little to less overhead or too much effort on the developer side. Compare that with WebSocket, it's going to be a little bit challenging. Of course, you will have to maintain certain IDs so that you can identify the connections that is there. Secondly, the no unbound buffer means that you don't have to handle the graceful connection closes. What it essentially means that all the data which is in the stream or in the buffer, if it gets lost, it gets garbage collected easily. You don't have to worry too much about it, right? So where is it being used? You might have seen in ChatGPT that when you type in your prompt, the paragraphs or the text or lines comes in bit by bit. It doesn't come out immediately. This is a very good example of a very good example of servers and events. The paragraph or the text comes in line by line. GPT or OpenAI streams that text towards the client, and then line by line it comes in. So the user doesn't have to wait for, let's say, 2 or 3 minutes to get the entire response. The user can start reading, and the response keeps on getting attached to the UI. Very good example. Location-based services. You might have seen when you order, you are seeing where your delivery partner is when you are ordering food, right? That is also, or you could, it's not essentially server sent event, but you could use server sent events for that as well. Server just keeps on sending the updated location of the delivery partner, and then just front end updates it accordingly. Monitoring system, very essential. You might have thousands, not thousands, you might have a few microservices here and there, and you need to monitor something. You can use or tell those microservices to stream data to one of your microservices, which essentially is going to be reporting or monitoring it and showing a good enough UI dashboard, right? So all these examples, stock tickers, live feeds, sporting event updates. Let's say, for example, CricBus. Whenever there is a cricket match, you can see that it gets updated in real time. You don't have to refresh the entire page, right? Just new data just comes in and attaches onto the UI. Very good example of server-sent events. Okay. So let's talk about what's under the hood of server-sent events. Now, server-sent events are based on HTTP protocol. That means you can send the request to the server, and we'll figure out how the server-sent events is able to stream the responses. So initially, whenever we are initiating the connection from the client side, we send an accept header saying that text/event stream MIME type should be the response type that I, as a client, is able to accept. The server responds correctly with saying that text/event stream is the type that I would be, as in the server would be sending in. Along with that, server also sends a connection header saying connection keep alive, which allows the server to stream responses back to the client. So this is how the connection stream or that tunnel is formed between the two things, which is client and the server. You also have an option to send out a reconnect timeout, custom timeout setting. Generally, it is 5 to 10 milliseconds or 5 to 10 seconds, sorry, which you can, of course, increase or decrease based on your need. You can also set up an optional header or an optional message type which you can send back to the client, specifying the last. In this illustration, we can see what happens exactly is when the client sends a connection request, it will send out the correct MIME type, which is text/event stream. The server will acknowledge it and correctly responds with the correct structure of the response back to the client. Now, once this happens, the connection has been made between the client and the server. Essentially, that connection keep alive setting or header allows the connection to be kept alive, meaning the connection is not closed. Now what the server can do, server can, based on certain logic, business logic or anything, can stream the event back to the client without ever client reconnecting or re-requesting the data. Server will keep on sending whatever data it needs to send, however long it needs to send. Once it is done, either the server can close the connection, or the client can reconnect. So this is how the server-sent events are being used. from the user's perspective or from the client's perspective, the client can manually close the tab or click on some button which can essentially close the connection. So this is how the entire structure of server-send event works. So let's look at the spec sheet. As discussed, the request is HTTP based, so we can have a URL on the server side saying let's say slash stream or slash anything for that matter. A get request with a accept header saying text slash event stream. The server will respond with the correct headers saying that connection should be kept alive. The content type should be text slash event stream. Now here we'll see transfer encoding in essentially saying chunk, which means that the server is essentially saying that the data is not going to be sent in one shot. Rather, it will be streamed in small bits and chunks to the client. Here we can say that server is also specifying a retry of 15,000 milliseconds. Then once this is sent back to the client, the server is now ready to send out the first data stream. Now in this slide, you can see the format of data is very specific. You'll have to send out the text-based response or text-based data, calling back to the point that HTTP is a text-based encoding, and we are sending text-based response through server-sent events. So the data field is essentially saying this is the data that I want to send to the front end or the client. You can have this as a simple string, you can have a stringified JSON, or anything for that matter, as long as it's text encoded. You can also see that you can essentially also give a name to the event. So you can have in the same URL have different types of events which can then be handled differently on the front end. Optionally, you can also give in an ID to that sent out event or data, which can be used for either front end to reconnect and start with the same event sequence that the server knows about. This way, this is how your automatic reconnection and automatic streaming of the same resumability increases from server-sent events. Now, one point to mention again is it's not required that you can have only one line of data feed. You can have multi-line of data feed. So essentially in one text or in one server-sent event that you'll be sending into the front end can have multiple levels or multi-line of messages. So first message, second message, and it's up to the front end. Either the front end should message the ready, keep on and get a right response and then show it accordingly to the user. That is highly dependent on how he wants to interpret this message, how to present it. So this brings to the end of part 1 of our server-sent events video tech shorts. In part 2, we'll go over the example code and we'll discuss the different other technologies that are present and talk about the limitations of server-sent events in detail. Thank you.